Welcome to our narration of Chapter 9 of the AP Statistics exam. We will be going over significance tests today. So each significance test begins with a hypothesis. Two hypotheses, actually. You have a null and you have an alternative. A null is representative of no change, of no difference between various sorts of statistics that you were given. And the alternative hypothesis is the claim that you are trying to receive evidence for. And this claim can either be equal to the null, or greater than, or less than, or not equal to the null. So you have one-sided alternative hypothesis, which would be the larger or the smaller, or the two-sided, which is different than the null. So each significance test, whenever you conduct it, results in a p-value, which is the probability that the test statistic will be a value as extreme, if not more, as the observed value. So how this relates to your significance test, you can tell whether or not your results are significant based on a specified level called alpha. And typically this will be 0.05 unless otherwise specified. And you can interpret the p-value by saying that in sample sizes of this size, the p-value is the percentage of samples that will result in values this extreme or more. So if the p-value is below alpha, we'd reject H naught, which is the null. Or if it's above the significance level, we fail to reject. So we can't confirm anything. We're either rejecting or not rejecting. There are two types of errors that can come from significance tests. One's a type 1, and that would be if we reject the null, but the null is actually true. And the chances of this happening are the significance level, which is alpha. And the type 2 error is when we fail to reject H naught when it's actually false. And the probability of this would be 1 minus the power. And the power measures the ability of a test to detect an alternative value of the parameter. And the formula for power is very complicated, so generally it will just be given to you in the problem if it is needed. Okay, so to carry out a significance test, you first need to check your conditions. You need to check for randomness within the study or experiment. You need to make sure the data is normal, and you need to make sure it's independent. And so if you've conducted all three of those condition tests and they check out, then you can start to compute your test statistic, which is represented by the equation on the screen. And then using a one sample z-test, you can use your state, plan, do, and conclude method to answer the problem. You can also use a confidence interval if you want to determine a range of possible values for the parameter p. So most times we don't know the population standard deviation, which is sigma, so we calculate a t statistic instead of a z statistic, which is represented by the equation on the screen. Again, you need to check for randomness, normality, and independence, and confidence levels will also be used for estimation of mu. Both the z-test and t-test can be found on your TI Nspire under statistics, stats test, and z-interval and t-interval respectively. So while statistics or significance tests test for the test whether data is representative of the whole population, the data of the sample that is. You still need good unbiased data to conduct the experiment or study with, because poorly collected data can't be made up with a significance test. So data that you want is free from outliers and free from various sorts of aspects that would make it biased.
So here we have an example of an AP Stats exam free response question. And so this one asks, when a law firm represents a group of people in a class action lawsuit and wins the lawsuit, the firm receives a percentage of the group's monetary settlement. That settlement amount is based on the total number of people in the group. The larger of the group and the larger the settlement, the more money the firm will receive. A law firm is trying to decide whether to represent car owners in a class action lawsuit against a manufacturer of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have that defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it is convinced that more than 5% of cars of this make and model have the defect. The firm plans to take a random sample of 1,000 people who bought this car and ask them if they experienced this defect in their cars. And so the question, part A, is asking us to define the parameter of interest and state the null and alternative hypothesis that the law firm should test. And part B is asking, in the context of this situation, describe type 1 and type 2 errors and describe the consequences of each of these for the law firm. So now we will look at an example response, which was a 4. So for part A, the parameter of interest is the true proportion of defect cars of that model. The null hypothesis is that that value is equal to 5%. The alternative is that it is greater than 5%. For part B, a type 1 error would be that rejecting the null hypothesis that the proportion of defect cars is 5% or less when it is actually true. The consequence of this error would be the law firm taking the case and not being able to recover the expenses, therefore losing money. The type 2 error would be failing to reject the null hypothesis that the proportion of defect cars is 5% when it is false. The consequence would be that the law firm not accepting the case in which they could have made money. And as you can see, this answer answers both areas of the question, which describing both the type 1 and the type 2 error and the consequences. So in order to get a 4 for this particular one, the entire question needed to be answered, just like in the example. And here is another free response question from an AP Stats exam. For many years, the medically accepted practice of giving aid to a person experiencing a heart attack was to have the person who placed the emergency call administer chest compression, also known as CC, plus standard mouth-to-mouth resuscitation to the heart attack patient until the emergency response team arrived. However, some researchers believe that the CC alone would be a more effective approach. In the 90s, a study was conducted in Seattle in which 518 cases were randomly assigned to treatments, 278 to CC plus standard MMR, and 240 to CC alone. A total of 64 patients survived the heart attack, 29 in the group receiving CC plus standard MMR, and 35 in the group receiving CC alone. A test of significance was conducted on the following hypotheses. The null hypothesis was that the survival rate of the two treatments are equal. The alternative hypothesis is that the treatment that uses CC alone produces a higher survival rate. This resulted in a p-value of 0.076. So the question for part A is asking us to interpret this p-value in the context of the study. Part B is saying that based on this p-value and study design, what conclusion should be drawn from the study? And we are to use a significance level or an alpha level of 0.05. And for part C, based on the conclusion of part B, which type of error, type 1 or type 2, could have been made, and what is the consequence? So here we have an example of what a 4 would be. So to answer the first part of the question, the student wrote, this p-value measures the probability of the difference of the number of people who survived that used two different treatments. For part B, the student wrote, at alpha level 0.05, we do not reject the null hypothesis. There is not significant evidence that the treatment that uses CC alone produces a higher survival rate. As you can see, both the questions were answered fully. And his answer for part C, which was talking about type 1 and type 2 errors and the potential consequences, the student wrote, based on the conclusion in part B that H0 should not be rejected, a type 2 error could have been made, meaning that the null was not rejected when it should have been. One potential consequence of this error is that the conclusion of the results that the treatment that uses CC alone does not produce a higher survival rate would be wrong, and therefore we would not be treating heart attack patients in the most effective way possible.